Hello, my name is Kürten. I'm Division Manager for Vehicle Architecture at FEV. Today, I would like to present you the Flex Body technology, which is a modular body-in-white solution with low invest costs. First of all, I would like to give you a brief overview about FEV in general. So we're a global engineering service provider located in more than 40 subsidiaries on 5 continents with currently 7,000 employees. Within vehicle development, vehicle architecture is one of our main fields and main, let's say, fields of activity. Flex Body at the end is enlarging our solution portfolio for the development of vehicle concepts, and one additional concept and tool we can use when we talk about the development of new body-in-white structures. To give you a brief overview about the idea and approach of Flex Body, so in general, it's from the idea, it's a modular and scalable body-in-white design kit, let's say. It's based on profile structures and nodes. It's developed really dedicated for lower quantities, which means we have the main focus regarding the manufacturing technologies and materials we use, that we are selecting the ones with very low investment costs. Regarding the material mix, we are able to mix different materials within the body-in-white structure, really according to the structural needs of project boundaries we have. And for sure, we are also using innovative and new joining technologies to enable this kind of material mix. Regarding the production process, we are considering a single-shot fixture approach, which means we eliminate several sub-assemblies. And our focus is to assemble and join the whole body-in-white in one big fixture. And depending on the material mix and depending on the tolerances we need to compensate, we are using, for example, injection bonding to handle these, let's say, boundary conditions. The whole process is really optimized for Flex Body. So that means starting from scratch with the first concept sketches up to the part manufacturing and assembly process, everything is really dedicated on this profile-based approach, including the virtual validation processes and concept development steps. From the economic point of view, compared to a self-supporting body-in-white structure or a space frame solution, the range where Flex Body is very attractive regarding the investment costs is from, let's say, a one-off prototype up to 30,000 cars per year, where we see roughly the break-even point, at least compared to a space frame solution. And this is one additional advantage. From the structure concept point of view, we are quite comparable to a space frame solution, I would say. So which gives us, if we consider the possibility for a ramp up or increasing quantities, which gives us the opportunity. This is only a brief overview with some exemplary materials we already used in the past. For sure, there can be much more. So at the end, we have, I would say, nearly the whole design freedom regarding the used materials, and we can mix, if we consider the right joining technology, we can mix nearly each and every material within the body, really, as mentioned, according to the structural need. That means we are able to optimize from the structural performance and weight perspective a lot in the body-in-white structure. For sure, it's not only the material, also for the manufacturing processes, we are considering processes with a very low invest for the profiles, for example, the extrusion profile or build profiles, or also fiber reinforced plastics with processes dedicated for lower quantities. And for the joints, we can start with a milling or milled node for a one-off prototype, for example, or industrial origami, which is also dedicated for very low quantities, up to conventional casting solutions. Depends on really on the approach of the project, but in general, all of these manufacturing technologies can be realized with a very low invest. The fixture concept I mentioned already. So the idea is to eliminate as much sub-assemblies as possible and go on with bigger assemblies to let's say be faster also in the assembly process. and simplify the number of subassembly steps. These are some, let's say, highlights regarding manufacturing and joining examples. On the left-hand side, the industrial origami approach, which is at the end assembly, where we can realize also inner topologies. It consists of very simple folded sheet metal parts which are welded together. In the middle, hybrid casting. So we have different approaches for hybrid casting. We can realize, for example, steel aluminum hybrid nodes, that we are able to cast the aluminum node with a steel sheet metal insert, which can be conventionally welded to a steel rocker, for example, or we can go more advanced with a co-casted profile, where we have we call it in-mold assembly process. So that means within the casting process, we are joining together the profile and the node and save additional joining steps afterwards. And injection bonding, which allows us to combine really different materials to be able to compensate tolerances and isolate different materials regarding corrosion protection. To summarize it very quick, so FlexBody is a profile and node-based design kit. It's developed with a focus on very low quantities. It's highly modular and scalable. The low quantities are already considered at the selection process of the material and manufacturing processes. And with new and innovative joining technologies, we are able to mix different kinds of materials. And to summarize it in one sentence, especially in the currently very dynamic world of vehicle engineering, FlexBody can be one solution for the efficient development of a modular body-in-white concept. Thank you very much.